Okay, fifth graders, welcome back. Unit 7, Lesson 13. We are going to be talking about division with decimals. You know what? It's like a regular division. I would ignore the decimals. You can see the work here. 9 goes into 34 3 times, which is 27. Notice that they put a 0 above the 3, and notice that the decimal came straight up in the answer. It's really important to line these numbers up with the numbers in the dividend here. Okay, so again, we keep going. We subtract, we get 7. Next step is to bring down the 2, which they did right here. 9 goes into 72 8 times, which is 72, and you get a remainder of 0. Okay, so the answer would be 0.38, or 38 hundredths.
Alright, boys and girls, on this slide I'll be showing you the process of long division as we solve it with a decimal. And you'll actually notice that with a decimal point it doesn't change very much. It's actually quite easy. So what I'll go ahead and do is I'll take this example problem. You'll notice that they show up above the steps using text to explain it, but I'm just going to show you. I'm a very visual person, so I'm going to walk you through it in my own way too. So essentially the problem they're trying to solve is if they have $20.25, they need to split it among 3 friends. So they need to split it 3 ways equally. So that's why we're taking 20.25 divided by 3. So the first thing we're going to do is we're going to look at, does 3 go into 2? No, it does not. So I'm going to put a 0 as a placeholder. These placeholders and where you place your numbers up top become more and more important as we get into decimals. So now I look, can 3 go into 20? My answer is yes. If I take 3 times 6, that will give me 18. Now here I subtract. I'll have to borrow from next door. So then I end up with 10 minus 8, which gives me 2. 1 minus 1, 0. Here's where I bring down the next number I'm working with, which in this case is a 2. Now as I'm working, I like to put the decimal in. With your answer, when you're dividing with decimals, unlike what you do with multiplication, all you do is take your decimal and boop, move it right up and place it in your quotient or your answer. So that's why you could see it will be really important that you're placing your numbers in the correct spot, because let's say I put my 6 in the wrong spot, my decimal would then be in the wrong spot as well. So now I have put my decimal up in my problem because I just got to it here right after the 6. I've brought down my 2 here to continue my problem, solving the problem. So now I think, does 3 go into 22? Again, yes. The closest it gets is 3 times 7. 3 times 7 gives me 21. So again, I'll subtract here and I end up with 1. Okay, the next number I have to bring down is a 5, so I'll bring that down here. And this problem works out very nicely because I know 3 goes into 15 perfectly. It goes in there 5 times because 3 times 5 is 15. So when I'd subtract, I would end up with 0 or no remainder. So as you can see, my work here is finished and I end up with no remainder. So then I would write my answer as dollar amount, so I'd put the dollar sign out front, and that would be $6.75 if those friends had to split it 3 ways. So this is an example of a problem with a decimal that works out nicely so that you don't have to worry about a remainder. And we will show you that later on in the video because we don't want remainders once we have decimals involved.
Alright, here we just have a couple problems that we can solve. You know what, keep in mind in your estimation, again, that's always important with placing decimals. We know that 8 on this first problem, 8 times 6 is 48. So our answer is going to be really close to 6. So we're going to see, I know that 8 will go into 47 5 times, which is 40. Remember, when you subtract, you always check and make sure that number is smaller than your divisor, which 7 is. Okay, I would sneak my decimal point straight up before I go across it to the next number so I don't forget. All right, I bring down my next number, which is 76. 8 times 9 is 72. I subtract, I get 4. I have one more number to bring down, which is 48. And 8 times 6 is 48. And when I subtract, I get 0. So my answer is 5 and 96 hundredths. You can see my estimation of 6 helps me place my decimal point. All right, number 9. Similar deal here. We got 9 goes. If we go 9 times 6, that's 54. When we subtract, we get 4. Okay, and again, decimal point goes straight up. Notice how my 6 is right above my 8. That's really important. Bring down my next number. 9 goes into 46. Oh, let's see. 5 times, which is 45. I subtract, I get 1. I bring down my 8. And 9 goes into 18 twice, which I can see it's not going to have a remainder again. So it's 6 and 52 hundredths. Now we're going to work on some problems later. They're not all going to work out this nice. Let's say I would have had a remainder here. Let's say I would have had 2 left over. But I have no more numbers to bring down. After a decimal point, remember we learned we could add as many zeros as we wanted to. Okay, so if I had a 2 left over, I would bring down the next 0 and that would make it 20. Okay, so that's going to be a skill that you're going to learn. Even when you run out of numbers after the decimal, you can add zeros and keep dividing.
Alright, boys and girls, on this slide we'll be applying what we've learned of long division and division with decimals to solve some word problems. Number 4 reads, Imelda has 8.169 or 8 and 169 thousandths meters of rope. She wants to cut it into 3 equal pieces to make jump ropes for her 3 friends. How long will each jump rope be? So because she's cutting it into 3 equal pieces, I know that I'm going to be doing division here. So I'm going to set up my problem down below. I put 8 and my decimal point here, 0.169, and that is being divided into 3 equal pieces. So my divisor then is 3. So I'll go ahead and start solving. Remember, you ignore the decimal until you're ready to place it into your quotient. That's why lining up your numbers becomes so important. 3 does go into 8, the first number this time. It goes in there twice actually, because 3 times 2 is 6. So when I subtract here, I'll end up with 2. Now before I do anything else, I see that my decimal is what comes next, so I'm going to place that in my answer or my quotient right away. So that's ready to go. Now I'm going to go ahead and bring down the next number here, which in this case is a 1. I know 3 goes into 21 perfectly. 3 times 7 is 21, so when I subtract, I'll end up with 0. But remember, I still have more numbers to bring down. That next number then is a 6. Okay? 3 does go into 6 again perfectly. It goes in there 2 times, because 3 times 2 is 6. When I subtract 6, I'll end up with 0. But then remember, I still need to bring down the 9 here. So then again, I have a nice, easy division problem because 3 goes into 9 perfectly as well. 3 times 3 is 9. So when I subtract 9, I ran out of room here to keep going, so I'm just writing it this way. I'll end up with no remainder, so I don't have to worry about anything here. My decimal is placed in the correct spot. So I would answer my question that it would be 2 and 723 thousandths, and then I see the unit of measurement they used was meters, so that's what I'll use to label my quotient or answer. Let's go on to number 5. This says Tonio has 7 and 47 hundredths pounds of rabbit food. He will divide it equally among his 9 rabbits. How much food will each rabbit get? So again, I can see it tells us actually exactly what to do. It says divide it equally. So already I know I'm going to be using division to solve this problem. So I'll put 7 and 47 hundredths. That's going in the house, or that's being divided into, because that's how much pounds of rabbit food he has to start with. And then I'm dividing that because he has 9 rabbits that he needs to divide amongst them. So I'm going to start by looking at, does 9 go into 7? No, so I put the 0 up. Because we're working with decimals, it's important to use the 0 as a placeholder. Because now I can see I'm already ready for my decimal point. Okay, so already my quotient has 0 point, or my decimal. So now I look at the problem, can 9 go into, I'm going to look at this as 74. Yes, I know that 9 times 8 will give me 72. So then when I subtract, I end up getting 4 minus 2, which is 2, 7 minus 7, which is 0. And then I bring down my next number here, which is a 7. Can 9 go into 27? Yes, it goes in perfectly 3 times. 9 times 3 gives me 27. So now when I subtract, I'll end up with a 0. No more numbers to bring down, so no remainders. So now I'm finished with my quotient, or answer. And I would answer this problem as 0.83 pounds, because I noticed in the beginning of the problem they said pounds of rabbit food. So that means each of his rabbits would receive 83 hundredths pounds for food.
Okay, this exercise is just helping you understand how to place a decimal in a division problem. Now we know these are all basic facts, like 9 goes into 63 7 times. Okay, but that 7 is going to go above the 3, so that means the decimal point is going to go right above it. So it's 0.7, or 7/10. Number 12, again 3 goes into 15, that's a basic fact, we know it goes in there 5 times. Again, that 5 now is going to go above the 5 when we set it up in a division problem. Notice there's a space and then the decimal, so we have to go 0.05. Okay, that 0 is going to come from that one spot. Okay, so there's 2 decimal places in that one. Okay, number 13, we have 6 into 4.8. Again, that's a common fact. We know that 6 goes into 48 8 times, but it's 4.8. So our decimal is going to go right in front of the 8, one place over. Alright, and the last one. We know that 7 will go into 21 3 times, but notice there's 2 decimal places ahead of it. So I'm going to put 2 zeros and add my decimal. Okay, so again, dividing with decimals, pretty easy stuff. It's just placing the decimal in the right spot.
Alright, ladies and gents, I'm going to show you another problem, how to solve it. And it does show you the process here off to the right, but I'm going to show you step by step so that you really get a good visual of how to solve these problems. Because this is where it starts to get tricky. Instead of using our answer with a remainder, we now start adding zeros after our numbers to continue the math so that we don't have remainders and instead just add on to the number. And I'll show you what I mean as we're solving here. So here we have a young lady who's running 6.65 miles every day for practice. She knows that if she runs half that distance and back again, she'll have run enough miles. So essentially we're taking 6.65 and we're dividing that by 2 because she needs to know how far she needs to go before she turns around. So we have to divide that in half, or divide by 2. So I'm going to start solving. I know that 2 goes into 6 nicely. It goes in 3 times because 2 times 3 equals 6. So when I subtract, I actually end up with 0. Before I bring down my number, I notice that my decimal is already ready to be placed. So I'll place that up in my quotient so I know it's in the right spot. Now I'll bring down my next number, which in this case is a 6 again. 2 goes into 6, again perfectly, 3 times. 2 times 3 gives me 6. So I'll subtract. I get 0 so far. Bring down my next number, which in this case is a 5. I know that 2 goes into 5 twice because 2 times 2 equals 4. So when I subtract that, here's where I'll get 1. But here's the interesting part of the problem. I don't want to say 3.32 remainder 1, because if you told this young lady, okay, well, you have to go 3.32 miles remainder 1 before you turn around, would that make any sense to her? Well, no, not at all. That makes absolutely no sense. So what we instead do is just add a 0 onto our dividend here. Now remember, we've taught you this whole unit and even in previous units that a number like 6.65 is the same thing as 6.650, which is also the same thing as 6.65000. So remember, putting that 0 on the end of our dividend, does that change our number at all, or the value of it? Not one bit. So essentially, we're just giving ourselves more numbers to work with. You can only add 0 on the end, though. That's the only number we add on. So now I'm going to take that 0 that I added and bring it down. So now down here, I have a 10. That's going to work out much nicer because I know 2 goes into 10 perfectly 5 times. So 2 times 5 gives me the answer 10. And now when I subtract, I get 0. So no remainders. I don't have to worry about adding any more work or any more zeros. So I found my final answer of 3.325, and then they were talking about miles in the problem, so I know miles will be my label. So again, we'll show you some more examples like that where you have to add a 0 to the dividend. Just be careful to remember that if you run out of numbers to bring down, we don't want remainders. Instead, just add a 0 on to the end of the number that you're dividing into.
Okay, we just have 2 more long division problems to solve. Again, I would encourage you to use estimation. Really, we have 6 into 54, which my estimate is going to be 9. And this one, I have 5 into 141. Well, I could round that up to 150. And 150, 5 times 30 would give me 150. So I know my answer in this one is going to be somewhere around 30. Alright, but it's going to be a little less than that. Let's go back to this problem. 6 times 9 is 54. Subtract, we get a 0. Okay, we put up the decimal point because we're going to cross over to the 7. Bring down the 7. 6 goes into 7 one time, which we multiply as 6. When we subtract, we get 1. And then the next number we bring down is a 5. Okay, 6 goes into 15 twice, which is 12. When we subtract, we get a 3. Now, this is what I talked about on a previous slide. Since we're into the decimal points, and we still have a remainder, we don't want a 9.12 remainder 3. We never show our answer like that. So we want to keep going. So I'm going to add a 0. Watch what that does. When I bring that down, that makes that 330. Now I can divide again. 6 into 30 goes 5 times. Okay? And which is 30. When I subtract, I get 0. So just adding that 1 0 helped me finish that problem. My estimate was 9. It's 9.125, 125 thousandths. Alright, similar type of problem. I'm guessing we're going to have to add zeros. And remember, once there's a decimal, we can add as many zeros as we want and we can keep dividing. Even if it's a whole number with no decimal, we can add a decimal and add zeros to it. So 5 goes into 14 twice, which is 10. Subtract is 4. Bring down the 1. 5 goes into 41 8 times, which is 40. When I subtract, I get 1. I'm going to bring up my decimal point straight up into my answer. Now I'm going to bring down the first decimal after, no, first decimal number after, and which is 2. And 5 goes into 12 2 times, which is 10. And again, I knew this was going to happen. I have 2 for remainder. Again, so what we're going to learn new this year is we do not put that up as a remainder, especially after we've placed a decimal point. We're going to add a 0, and we're going to follow with our pattern, bring down that number, and that's going to make that 20. 5 goes into 20 4 times, which is 20, and we finally get 0. Now, something you might see is you might start seeing a number repeat. Remember, we show a repeating decimal with a line over it. Okay, so if you see a number repeating, don't keep doing it for on because it'll go on forever. So just once it repeats, you can stop there and put your answer with a line over the top. But these two did not have repeating decimals.
All right, ladies and gents, before you complete your ticket to class, I do have a challenge problem for you. This one you will have to add a 0 to the dividend. Hint, hint. I want you to solve 2 and 358 thousandths divided by 5. Keep in mind that that's a decimal place there. So take your time, show all of the work, and I want to see that answer on your ticket tomorrow.